Dobar dan, dragi posjetitelji. Nastavljamo sa zadnjim setom predavanja koji otvara Valent Turkovic sa otvorenim hardverom i mesh mrežama.
Hi everybody. So first I'll give just a short background who I am and what I'm doing here. So my background is I started with wireless networks really early on in 2003 when we started building wireless community networks. And the first time I climbed the building, I was hooked. So connecting people and climbing buildings was really a big hook for me. So I continued working on this even to this day. One of the things I also worked with was developing a Linux distribution called Fusion Linux. And it was during 2010 to 2013, and it really became really popular in this short amount of time. And you can even see some unknown distro here called Arch trying to catch up. But yeah, Fusion Linux actually topped it at that time at least. So also I started co-founded Hackerspace in Osijek. And then in 2011, we migrated our current wireless network into an open project because all wireless networks were like closed. You had to be a member. You had to pay some kind of membership to some kind of association. You have to be a member to join in. And we just flipped this model on its head. So we created an open network in which anybody can join, anybody can build wireless infrastructure, and it was really easy to do so. And yeah, this was a video really early on when we were starting, but actually what we predicted we actually built in these few years. So in this video we said like we'll create like 100 nodes and we'll connect multiple countries, and yeah, actually we did all this. So we have nodes and international links between Croatia, Slovenia and Austria, and more than 400 nodes in the network. And it's the biggest mesh network, Babel mesh network in the world. We have some kind of, I think that we have around up to 10,000 clients in the network each day, and multiple terabytes of data going through it. So network is really stable, and it's been built and improved each day. And it really proved it's really robust and it actually works. So just general, I'll explain just for those who are not familiar with wireless mesh networks, what's the idea, what's the point of using mesh networks. So the idea is that when you use your home network, each node, each hotspot, each router you have, it's a completely autonomous system. It's not connected to the rest of the devices. And with wireless mesh networks, you can put more devices in one place, and they will interconnect and build one network that's actually a real network. So they just connect, they exchange routing data, and then you can use the you can have multiple benefits using that. You have more robust networks. You have it's easier to manage if you do it properly. And also, I'd like to give a really huge shout to OpenHR, because they really saved our asses, because when we had a really catastrophic failure with Thunderstruck on our main node, they helped pitch in to replace the equipment. So yeah, huge thanks, guys. So and now for something really completely different. So in 2015, there was a really big migration crisis, because Syria was part of, as you know, war, and there are lots of refugees. And it's actually a really similar situation, because whoever is a little bit older here in this audience probably knows when Croatia was part, and when we were fighting for independence, we also were, lots of us were refugees. So it's completely different, but still something familiar. And what happened then is that nobody was prepared for a crisis of this scale. Everybody was thinking it will be a few hundred people, and on the first day in Croatia there were like 5,000 people, and nobody was. It was complete chaos. So all the NGOs, all the service organizations that tried to help something were completely swamped, and they were like paralyzed. This also is through with crisis communication. So that when 2,000 people come in some small area, what happens is that all the networks collapse. So all the major national networks completely collapse. So T-Com, VIP, Tele2, all the networks just collapsed. And people couldn't communicate, not even the rescue services, the military or the police. And we came there with a backpack, and we tried to do something that they couldn't do. So it was really a crazy idea, actually, but it actually worked. Because we were real stubborn, and we tried to do something that nobody did before, to build a network not from the top down, but from bottom up. From small nodes, but that could connect to the remote towers that were not overcrowded. We brought the internet locally. And I mean, it seems like a simple idea, but none of the really big organizations managed to do it. And there were like all the biggest NGOs that were in the field, like Red Cross, Greenpeace, UNICEF, and they were like completely, they didn't know what to do. So first versions were like these mobile towers. We used off-the-shelf components, and we built with gear that we could buy in the normal shops. But we connected to the solar power and batteries, so they were completely autonomous. Because in the middle of the field or some refugee camp, you don't have power. And this was power was really big topic to handle. And afterwards, we were called to partner with one company to bring Wi-Fi in the whole refugee camp, and to do it in less than 3 days. And we accepted that. And we are also crazy for even trying to do it, because people, whichever company tried to do something similar, they would say they need at least a month to do something like that. Croatian Telecom tried to do it, and they managed to do it only after 3 months, and we did it in less than 3 days. We built components, put them in boxes, isolated them so that they could handle hot and cold weather, and climb these big towers, which were rusty and not used for over 20 years, and it was even a risk to climb up there. So we climbed up there. I took these photos from the tower, and we put the equipment there because this was the only location that we could get power and good position. So we connected 2 lampposts, and we got power during the night, and during the day we had to use batteries. And we also created lots of small mobile kits that we gave to smaller NGOs, so they managed to have internet connectivity all over the place, wherever they were. This was one border crossing. And also we put permanent hotspots in asylum centers in Kutina and Zagreb. So, I think it's video, or no? Empty slide. So what were the lessons learned? Actually, we learned that it's not important to have the best equipment, but to make it really simple. Because in the field, you don't have network engineers. When there's a crisis, there are no network engineers don't just pop up from the fields. So you have to have equipment that can be used by normal people, like first responders. And we try to find something like that, and it doesn't exist. So it really has to be simple. As I said, it has to be really crisis, actually, idiot-proof. It has to be autonomous, so it has to run on batteries, solar power generators, and any type of power you can get. It has to be scalable, because if you have a router for 10 people, you can't put it in a camp with 10,000 people. It just doesn't work. So you have to have technology that's scalable, and we use our network, which is really scalable, that uses mesh routing and software-defined networking to make it really scalable. And also, if you don't have a remote management, then you have no idea what's happening. If it's working, if it's not working, you just put it, and you go to home, and you don't know what's happening. So you have to have, of course, monitoring and management. So that's how idea of MeshPoint started. We actually thought we could buy something that exists already, but there isn't. So this is how idea of a new product came, and we call it MeshPoint. So it's really first open source, open hardware, autonomous Wi-Fi router for crisis situation. Actually, in the beginning, it wasn't as pretty as in this previous render. We started with just some pipes, putting 3D printed whole cover for the bottom, and try to use something. But we iterate really fast. So then we create a second generation of prototypes with 3G modems, built-in batteries, and external batteries, and we had really tough testing. We had really strict testing engineers. And after that, in the latest version, this is how current versions look like inside. So we have 3 Wi-Fi routers, interconnected, PoE powered, so we have only one cable coming in, batteries, so it can run for 6 to 7 hours, and then you have time to connect solar panels and generate it, but it has to run automatically as you just put it in the field. So you just turn it on and it just works. Yeah, so what's the path and where do we go from here? So we have a working prototype. Then we got a really huge prize on Europa's competition. We got awarded for Best Humanitarian Technology of 2016 by UNICEF, actually. So actually by the people who need this technology, not by just some random group of judges who don't know even what it is. So we got this award from really the people who need it. And they awarded us because they need it in the field. And then we started partnering with different organizations. All of these organizations were either our current partners or we had or we were doing some project with them before. So the question always is when we talk about open hardware and open software, is it even possible to do anything about it or is it a hobby project, or could you make it sustainable or could you actually make money and sustain a company? So there are quite a few good examples of people doing exactly this. Sparfan Electronics is one of the good examples. They have more than 130 people employed and really good profits. And also there are different projects that you see. Some did it like organically, some did it via Kickstarters and different crowdfunding campaigns. And there are just people making it and selling it, like Prussia from Czechoslovakia that made a fully open hardware 3D printer that actually got awarded also as the best 3D printer of 2016. And yeah, these 3D printers are also printing their cells actually. So all the printers, you can see that printer in the hall. All the parts were printed on the same printer that's being sold. So yeah, it's a really interesting concept. So yeah, there are different business models if you want to start an open hardware and open software company. But most of the people don't even think about the really good models. First, what most people think is that you just get a patent, then something happens, and then you have profit. So that's the general idea how to make money. But actually, this of course doesn't work. So actually, my question is to you. Do you know how many patents does really famous company in Croatia has, like Rimac Automobili? How many patents do they have? Do you know? Can you guess? 0? Who has more or less, maybe? 3? Okay. More or less, who? 100? 4? Okay. They actually have 0 patents. And they just raised I don't know, $200 million or something, yeah. So yeah, actually you don't need patents to make money. You have to have a good business model, actually something that other people want to pay for you to produce. So having patents and not having patents, actually having patents is mostly detriment. So it's actually a call for somebody else to sue you, not to protect yourself. So that's actually, and also there's some statistics that 20% of cases in German courts are now patent troll cases. So it's really rampant, and it's really, if you create a patent actually, and if you don't have a lot of money to defend it, you just call other companies just to sue you and take your money. So it's really, and this is whoever is working with open hardware, and even not open hardware, knows this, but most of the investors don't know this. So they just ask you, if you don't have patents, we won't give you money, and that's it. So there are really not so many investors that are clued into the patent issues. I see few ways that we can actually get some money and continue development. That's creating turnkey solutions on project basis or just selling services, because we can either sell you MeshPoint, or we can just put MeshPoint in the field and offer it as a service for humanitarian organizations. So, and also, we are creating on our platform is fully open source, but we are now working to make it more accessible to organizations, because the current version is only created for individual users, and organizations have different needs. So we are making a new version that you could use, and maybe have like first 5 hotspots free, and then you can pay some kind of a license fee for using it. Or you can just spin off your own server, and that's it. So also, what we are now working, we have applied to Hecate Prize. This is an international competition which calls all types of people, companies, individuals to present their projects. And only thing that it has to be open source, really good documented, and it has to be for public good. So we are now in this competition, and we are open to collaboration with any type of person who wants to join us, actually. So if you are hardware, software, whatever kind of background you have, or you're just passionate about technology, just contact us, and we'll probably have a place on our team for you. So I would like to take questions or comments. Has anybody seen some other examples of open hardware that are like really successful? Is anybody tracking some other project that are interested, like? Yeah. So these devices are completely 3D printed. So inside we have these three routers you saw, and this is also a smaller version that you can. So the idea is you take an off-the-shelf component router. Of course, this is not glued in, so it's it has fallen off. So you just take a Wi-Fi router that's for indoor use. If you 3D print a case, you can use it outdoors. We have deployed this like more than 550 or maybe even more in our network, and they really work great. So once you put OpenWRT on it, this is completely different router. So you buy a cheap router, which actually is cheap because the software is not so good, but if you put OpenWRT on it and mesh Wi-Fi routing system, so then you can really have a really good router. And we proved it in a crisis situation, as I said. So people who were trying to do it with even much more expensive equipment failed, and we did it with really accessible hardware. So the idea actually is in the future how crisis situations are handled is that when there is where crisis is somewhere, you send really high. You have teams that are really highly trained, and they go there. But this doesn't scale, of course. As you probably know, if there is some kind of crisis distributed, one team can't be in 10 places at the same time. Idea is if we deploy MeshPoint to all these places, we can actually drop it from the sky, deliver it by drones, whatever, and you can set up crisis communication in a matter of hours or days, not weeks and months as it's usually the situation. Yeah, that's it for me. Thanks.
You printed this for the outdoor use. Mm-hmm. How much is the UV resistance? Do you experience some degradation of material, or does it work normally in the rain, sun, and so on?
For example, this PETG material is completely UV resistant, so you don't have to do anything. Especially just put it outside and that's it. For example, this is PLA. It's not UV resistant if you don't coat it, but you coat it with some kind of lac spray, car paint, and that's it. It's really easy. Okay, thank you guys.
A sada slijedi predavanje od Emira. Raspodijeljeni datotečni sustav BGFS. Samo da ga spojimo na razglas, pa čovjek preuzima.